The inventory costs come or incur from two things that may go wrong. Either you have too much or you have too little. So all the costs are related to that, and a substantial part of this cost is actually related to the lead times. That is where we get the inventory from, which leads to a substantial part of the cost. And that is the focus of this video, to see how the lead time associated with inventory influences the costs. So we had in the previous sections looked at these five costs associated with inventory, or five types of inventories. And what happens is, cycle stock is the stock because of the certain process that we employ. So if I have a manufacturer or a supplier who's far, far away, naturally I would buy in larger quantities. I would ship in larger quantities. So my cycle stock goes up, my inventory goes up. Because I am shipping something from a distant location, I have to ensure the safety for a greater number of period, because higher transit time, so there is higher amount of uncertainty, so my safety stock is probably higher. The decoupling inventory, because I'm buying something from a distant location where I don't know what's happening, I would like to be more safe from the uncertainties of that distant location. So probably I'm also carrying higher decoupling inventory. And naturally, when I'm buying something from far away, the pipeline transit times are higher. So the pipeline inventory or the transit inventory is also substantially higher. So while these costs are pretty easy to calculate and visualize, there are some other costs which are not as easy to visualize, and that cost is associated with the ability to be flexible. And that is what I'm going to highlight here in a little bit through this inventory sheet, of how lead times affect inventory and affect our abilities to be flexible. So consider these two cases that we have here. The case one at the top left is buying something from far, far away. Lead time is 3 periods, and order quantity is 120 units. So whenever I order, I have to order 120 at a time. I am going to assume that my closing stock from the previous end is 90. I'm going to do that for both situations. Even for the close situation, I'm going to say that I have a stock of 90. Near the lead time is 1 period, and the demand or the forecasted demand is given to us for all these periods. Now let's assume, so let's create the sheet, let's create the model and the formulas so that our life is easy. So first is the formula for closing stock. Closing stock is previous closing stock plus what I get minus what I use up. All right. So what I had is the closing stock. What I get, those two make the total stock, minus what I use up is what goes out of the system. So what gets left is the new closing stock. So this is equal to what I had previously, plus this is what I am going to receive in the current period, minus 30 is what I'm going to use up in the current period. So this becomes my closing stock, and I'm going to copy this formula in this line, and I'm going to take this here, Control C, and paste it here. So I have my closing stock formulas very clear. Now, planned order release and receipt are a little bit difficult to understand, but think of it like this. Release is when my supplier ships the material, releases the material. Receipt is when I or the buyer receives the material. So if the lead time is 3 days, I want something in period 4, the supplier has to release the material in period 1 because the lead time is 3 periods. So if I need something here, I only will get it if it is released here. Okay, so in the first period, so if I release 10 units in the first period, I will get 10 units in the fourth period. That's the idea of release with the lead time of 3. I'm going to copy the 0 and paste it here. The same thing for near situation, but the only thing is lead time is 1 period. So if whatever I need in second period, I can order in the first period. The lead time is just 1. Enter. And I copy this everywhere. And so what happens is, as soon as I order something, my supplier will put it in transit and it becomes part of my transit or pipeline inventory. So let's start planning the sheet. So there is a negative here. I don't want a negative. I want to satisfy all the customers. So I want to receive something in fourth period, right? So I want to receive something in fourth period. I should order something in the first period, lead time of 3 days. So I order 120 units, which is our batch size or order size. Wonderful. So as soon as I order it, the supplier puts it in transit, so it becomes my in transit inventory. It's still in transit in period 2, it's still in transit in period 3, and I finally get it in period 4. I look at this again. There is a negative in the 7th period. I want something in the 7th period, so I need to order it in the 4th period because lead time is 3. I order it here, 120. The supplier puts it in transit, it's in transit, it's in transit until I get it in the 7th period. Now if I look at it, the negative comes in period 10, the negative closing stock, which I don't want. So I want something in period 10, so I need to order it in period 7 and it'll be in transit for 3 periods. And finally I get it and there is no negative. So fine, I am fine with this kind of ordering pattern. Okay, which is giving me, so my average inventory in this case is equal to average of the transit and the closing stocks. So it is 76.3. That's my average inventory. Let's look at the same scenario here. I have a negative in period 4, so I need something in period 4. I order 120 in period 3 and the supplier will put it in transit, and as I'll get it in next week, it's no longer in transit. I have a negative in period 7. I need something in period 7. I order 120 in period 6. It's in transit here and I get the material. I have a negative here, so I order something in period 9. It's in transit because again the transit is only one period because that's a lower lead time, and that's it. I'm fine. So if I copy this average inventory, we immediately see that we have lesser inventory to carry if we are getting something from nearby. But that's just one part of the story. So let me just put this as case 1, and here is the average inventory, which is equal to 76 something. Okay, and I'm going to copy this same numbers, and the inventory is 60 something or 61 something. Now let's suppose due to some disturbance the demand in my country drops to 0 for the next second and third week. After that it'll go back to normal, but something happens, the demand goes back to 0. I've already placed this order, the first order in the first week. I've already placed this order here. I can't do anything, it's already in transit, but I can do about everything else. So I'm going to try and change those future orders, right? So I see negative, I see a negative here, so I need something in the 8th period. So I will have to order it in the 5th period, 120, and it stays, I am sorry, I have to order it in the 5th period, 120 units, and the supplier puts in transit for 3 periods till I finally get it in the next period. There's a negative 10 happening here, so I need something in the 12th. I will have to order it in 9th, the lead time of 3 again, it's in transit. All right, so my inventory went up to 91, right? So in case 2, my new inventory is 91, average inventory is 91 units. Let's do the same thing for this near situation. I have 0 here, I have 0 here. I have not placed any order. I can completely remake my situation. I delete these two things. I have a negative in period 5, so I order 120 in period 4. I get 120 here. I have a negative in period 8. I order in period 7. I have a negative in 12. I order here again, one period of before that, and that is in transit. If you look at that, now my average inventory is 67 in case 2. So what happened was my business went down in case 1, my revenue reduced, in case 2, my revenue reduced because my sale has gone down, but my inventory has gone up. So even though my revenue has reduced, my cost associated with holding inventory would go up if I'm ordering from far, far away, which makes me relatively less flexible. So I might have to create a promotion or do something to get rid of that excess inventory that I have and generate some cash. In case 2, which is the near situation, well, as my the reduction, the increase of inventory was not as much, and I could actually, I would might have to do some promotion, but I don't have to resort to that promotion as much as I had to do, because there's almost a 15-point increase in inventory in the far, far away scenario, as I would have to do in this near situation. So there is a very minimal increase of inventory. Now let's look at the second situation where the inventory, the demand actually goes up. I know there is something special happening. So the demand goes up for the 2 periods. Again, then it's back to normal. So I have not placed any order. Let's start with the near situation first. Well, I having a negative here, so I can tell my supplier to ship 120 units here. It's in transit for 1 period. And then there's a negative here, so I tell my supplier to ship 1 period before. It's in, and then there's a negative here, so I tell my supplier to dispatch 1 period before. And there's a last negative here, so I need something here. I tell my supplier to dispatch it here, and there's 71.667. But so yeah, now what happens in this scenario? If you look at this scenario, I have already placed the first order maybe. So let's delete these 2 cases. I have a negative in period 3, negative 30. Okay, and if you look at it, there is actually no way I'm going to be able to satisfy this 30 whenever I just can't order, because if I order in period 3, if I needed something in period 3, I should have ordered it in period 0, which is not possible. So either I airlift this, have excess transportation cost, or I lose demand. So even without going into this idea of average inventory, sometimes because we are ordering some things from far, far away, it creates a loss of flexibility. And if there is a spurt in consumer demand, we would not be able to meet that consumer demand. So what we saw in this video is this idea that many of the inventory costs, we saw 2 broad categories: cost of not having enough or not having too much, are related to lead time and from where we buy that inventory. So in a normal situation, the higher pipelines or transit would mean that generally when we buy from outside, our inventories are higher. But a bigger problem is the problem for flexibility. If there is a substantial reduction in demand, if we are buying from far, far away, there would be a substantial increase in our inventory. So our revenue reduced, but our costs have gone up, which creates a substantial hit on our profits. If you are ordering from near situation, well, the increase is not as much. So the hit that you get is not as much. As far as a spurt or an increase of consumer demand is concerned, when you're ordering from far away, there are situations where it's impossible to meet a spurt in consumer demand, or we'll have to spend excess on airlifts or whatever to manage that consumer demands. In near situation, it's a lot easier. If there is a spurt in consumer demand and we have a good supplier, we can work with that suppliers to manage the change and serve our customers. In the next video, we will have a better idea on some other costs of inventory and what to do about them.